So good morning everyone. Welcome to the GATE Academy. So today this is a score booster fluid mechanics session. So we are having a score booster fluid mechanics session today. So first of all, I would like to welcome you on the behalf of the GATE Academy. All right. So in this session, we are going to discuss some important concepts as well as some important questions of fluid mechanics. Okay. So my dear students, my name is Umashankar Tripathi. As you can see on the screen, hello, good morning. So as you can see on the screen, this is a fluid mechanics score booster session by me. My name is Umashankar Tripathi and I am a PhD scholar at IIT Roorkee. PhD scholar, we call research scholar as well. Yes or no? So I am a research scholar at Indian Institute of Technology, Roorkee. Okay, so before PhD, I have done my MTech from IIT Roorkee itself. And about the GATE, if I talk about my GATE history, so I gave GATE in 2014, in which I got 65.66 marks with All India rank of 916, with All India rank of 916. Okay. Again, I have given in GATE 2015. In GATE 2015, I got 76.02 marks with All India rank of 643. So before moving with the session, I want to tell you something, guys. What I want to tell you is, and all of you, the students who are live, good morning everyone, good morning Piyush, good morning Dinesh, good morning Akshay, good morning Amitosh, good morning Mahendra, Satish, good morning everyone. So before I move ahead with this session, I want to tell you something about myself, like good morning. So I want to tell you something about my GATE history. Okay, so before entering to this GATE, I was working in BHEL. Okay, BHEL, I think all of you know. So when I started preparing for GATE examination, I targeted somewhat around 65, 66 mark, because if you see in GATE 2013 till GATE 2013, this was the trend. Till GATE 2013, this was the trend. What was the trend? If somebody is getting 65 marks, he is getting All India rank below 100. All India rank below 100. But as you can see, I got 65.66 mark, but my All India rank was nowhere near 100. Nowhere near 100. Now, how does it affect? So this IIT Roorkee, couldn't be IIT Bombay with this rank. Getting my point or not? Okay. As I was already in PSU, there was no point that I go to PSU again. So the thing is, I wanted to get IIT, some better IIT, some good MTech, IIC Bangalore or something. But with this rank, I couldn't get it. Okay. Now, in GATE 2015 also, I attempted, not for the purpose of taking admission somewhere, just to judge myself, because I was teacher then. I was started teaching from last 8 years. I have been into this profession of teaching for competitive examination, including GATE. So in GATE 2015, I got this much marks, 76.02 marks. I'll tell you something. If in GATE 2014, somebody is getting somewhere near 75 marks, he is getting All India rank below 100. So what I'm trying to say, what I'm trying to tell and what I'm trying to establish here is, see, every single mark is very, very important, especially in GATE examination. As you can see, if in GATE 2015 I could have reached some 5-6 marks more, I could be in a better IIT. Getting my point or not? So this is why because this session is very, very important. As you can see, this is a score booster session. What is this? This is a score booster session. So in this score booster session, what we are going to do, what we are trying to establish. So we are trying to we are trying to increase our mark this way, because as from my history you can see, you can judge there's this much marks, how important the marks are. Okay, so when you are getting marks above 60, 65, 70, then every single mark is very, very crucial. Every single mark is very, very crucial. Within 1 mark, 2 marks, the ranks of GATE shifts like 50 ranks, 50, 60, 100 rank will go up and down, as you can see here. So this, in this fluid mechanics score booster session, what we are going to do, we are trying to quickly go through the concepts we see in fluid mechanics. Okay, the kind of question that can come. Okay, this session will help you to form a stress. Good morning. Sure. So this session will help you form a revision strategy also. See, revisions are very, very important. When we are preparing for GATE examination, revisions are very, very important. Okay. And many students are ask me, sir, how to revise, sir. So many subjects are there. So we are trying to discuss that also. We are trying to give you tips on that also. Okay. So in this session, what is our target? In this score booster sessions, we have 3 sessions in this. So in these score booster sessions, we'll try to cover as much as topics of fluid mechanics we can, and we will try to do the questions, some good questions we're going to see some good questions of GATE examination also. This question we have done, how we can do it, how we can revise easily. Getting my point or not? Now, before moving to this, I want to give you some more data about the GATE examination. So as on the screen you can see, you guys can see the margin, the percentage of marks which from last 8 years from different subjects. This is an analysis. So in this you can see like, talking about fluid mechanics, as we are talking here for fluid mechanics. This is a fluid mechanics score booster session. Good morning, everyone. This is a fluid mechanics score booster session. So you can see this is fluid mechanics only, not machinery. So it is asked in 6 marks 2012, 6 marks 2013, 9 marks 2014, 9 in 2014. There were 4 sets. Okay, so overall in 4 sets, if we take percentage of the amount of the number of questions asked, it is 9%, 15, 7%. 3 sets were there in 2015, 2 sets were there in 2016, 17, 18, 19, and 20. So you can see almost, if I take average of all these, fluid mechanics itself only without fluid machinery is getting asked in about 8 marks, 9 marks. Now, let me tell you, if you are getting marks somewhere near 70, 75, and these 9 marks, if you can obtain, your life will be shifted altogether. If you want to go to PSU, you will be getting better PSU. If you want to go to like IIT, you will be getting better IIT. If you like these 9 marks, if you are getting like let's say you are having somewhere near 50 marks and you can attain this 8, 9 marks, 7 marks, so you will be getting better NIT. So these marks, you understand, these marks are very, very critical, very, very crucial beta. Very, very crucial beta. So in that note, we are going to start this. Fluid mechanics session. We are going to start this fluid mechanics score booster session, and I'll hope that the students who are live here will definitely respond to me, and will try to solve the questions as well. So see. On the screen, you can see I have divided this whole fluid mechanics in a kind of a way that what we are going to see, what we generally see. Tobin, you are asking, sir, maximum age limit to PSU for general beta. It depends upon PSUs to PSU. Some PSU it is 25 years, some PSU it is 25 years, some PSU it is 30 years. But for general, mostly not more than 30 years. Okay, not more than 30 years. Okay, so 25 years is the most of the PSU are doing 25, 27, 28. Some of the PSU are taking till 30. Okay, but if above 30, if we talk, there are state PSUs who are taking. Yes, Lata, this is for civil also. This is also for civil. Okay, okay. So on average, this is 27 years, as Shaurya you are saying. Okay, on average, you can say it is 27 years. So let's begin with the session. Let's begin with the session. We are here to boost our score. Okay, so let's see how we can boost our score. So I have divided this whole fluid mechanics, and we all must have read, because since it is December, so I assume all of you must have studied fluid mechanics, must have studied fluid mechanics. Okay, okay. So these fluid mechanics we can divide into this four portions. One is fluid statics, one is kinematics, one is dynamics, and the rest is, I called it miscellaneous. I called it miscellaneous. So in civil engineering, there is one more topic, that is open channel flow. I have not included that into it. Because no Piyush, no Piyush. Okay, because this is a combined section of civil and mechanical, so we are going to deal the things which are combined in both of the topics. Okay, so open channel flow, for open channel flow we may have a different section. All right, so broadly we can divide this fluid mechanics, in these four topics. Varun, good morning. So we can divide in this four subtopics. One is fluid statics, one is fluid kinematics, one is fluid dynamics, and other is miscellaneous. So how do we study these topics? So if I subdivide these topics, so in fluid statics, we have chapter number 1 named as properties of fluid. Chapter number 2, pressure and its measurement, in which we deal with manometers and all. Now, in this GATE year, some of you believe that some manometer is no more in the GATE syllabus, but it is not like that. Beta. Okay, because manometer, even if it is not written, manometer can be applied in dynamics also. You can see the use of manometer and venturimeter in the problems of Bernoulli equation. Okay, so anyhow we have to study it. Getting my point? The third topic of fluid statics is hydrostatic forces of surfaces, and then it is buoyancy. So these four topics constitute fluid statics. When we combinedly, yes, Akshay, if you even have not studied this subject, this session will definitely going to help. Definitely it is going to help. Okay, because I will discuss the concepts also briefly. Okay, so if you see this session, it will definitely going to help you. Okay, this is a promise, and at last I'll ask you guys if this is helpful or not. Okay, then you can tell me also. So this fluid static, these are the four chapters. Okay, fluid kinematics. So in fluid kinematics, I have divided into two ways, because in fluid kinematics we can see the kind of questions in which the input data is given in the vector form or input data is given in the scalar form. That is why I have divided this topic in this two way, vector and scalar. Okay, then fluid dynamics. In fluid dynamics, we mostly have to deal with the Bernoulli equation. When we are okay with this Bernoulli equation, when we understand the Bernoulli equation well, when we understand the use of Bernoulli equation well, when we understand the Bernoulli equation, and we can easily do the pipe flow with the 2 or 3 additional formulas. Okay. Similarly, we can do this vortex motion also with 2 or 3 additional formulas, and we can do this compressible flow. This compressible flow is a newly added topic in this GATE 2021 syllabus. In 2021, this compressible flow has been added. In 2021, compressible flow has been added. Now, apart from these topics, we have some other topics also. Named as boundary layer theory, dimension analysis, laminar flow, and turbulent flow. Now, let's begin with fluid statics. Okay, we are going to begin with fluid statics. So see, beta, we are very shortly going to cover the concepts here. So in fluid statics, beta, the first topic is properties of fluid. And whenever we are going to give some examination, do analyze the examination. before you go to it. Okay, semesters also we do the same way, na? Before going to write the semester examination, we always go through previous year question paper. Yes or no? Previous year question papers. Yes or no? Why we are going to through previous year question papers? So that we can little bit understand the pattern of the GATE examination. So if I say the GATE examination is 90% numerical based, 90% numerical based paper, so will that be right or wrong? Will that be right or wrong? So 90% numericals are there. When we are talking about this GATE examination, 90% is numerical, 90% is numerical, isn't it? Now, if 90% is numerical, what we can do, like if we are going to study this fluid statics, so how we can study this fluid statics, how we can quickly revise, how we can sum up the concepts of this fluid statics, so how we can do it. So the first topic is properties of fluid. The first topic is properties of fluid. Now in this properties of fluid beta, the numerical can be asked very firstly from this topic, very important topic, Newton law of viscosity. Now this Newton law of viscosity, if we see this Newton law of viscosity, we generally see, I have made a formula sheet for you guys like this. Okay, I'll share this to you. After the end of the sessions, all the sessions. Okay, so you can refer to it. This will help you in quickly revising the concept as well. So in this properties of fluid topic, we have this Newton law of viscosity, and in this Newton law of viscosity, see, if some examiner wants to frame a question from properties of fluid and he wants to frame a numerical, it is very likely that it will touch the Newton law of viscosity. And the second thing, GATE is taking place from last 35 years. GATE is taking place for last 35 years. This comment is for those who just have started their preparation from maybe from October, from November, and see, some of us are thinking, sir, how it is possible in October? Everything is possible. Nothing is impossible. Getting my point? Nothing is impossible. Okay. So if the GATE is happening from last 35 years, so in this properties of fluid, most of the theoretical concept they previously have also asked, and GATE have this tendency not to repeat the question. They generally do not prefer to repeat a question. Okay. Now we can take advantage of that also. Okay. Now, if we go for numerical part, the first thing in properties of fluid is Newton law of viscosity, and I have written it with red. Prakash, definitely I'll provide the PDF. I'll provide the PDF of whatever we are discussing. Here, we'll provide the PDF. Okay, these all important formulas I have written here, beta, for you guys only. Okay, so this Newton law of viscosity, this is the first thing that we need to revise, we need to observe. Okay, if we want to strike the numericals. Okay, so in this Newton law of viscosity, beta, see, in this Newton law of viscosity, we have these two formulas. If you go through the questions of it, you can say, sir, we can divide these questions in two types. Type 1, Newton law of viscosity questions in two types. Newton law of viscosity questions in two types. Okay, one in which we are using this formula, tau is equal to mu du by dy, and I am sorry, I made my mu like this. Okay, those students who have studied with me understand this is mu. Okay, dynamic coefficient of viscosity. Okay, so this is, we can say, sir, these can be framed as type 1 problem. We can say, sir, these are type 1 problems in which this formula is applicable. Now, how these type of problem will look like? So you will be given some equation like this. That's u is equal to 3 by 2 y square minus y, and this mu, which is called as dynamic coefficient of viscosity, let's say 10 Newton second per meter square, 10 Newton second per meter square. So this is my dynamic coefficient of viscosity. This is my dynamic coefficient of viscosity. Now, if this equation is given and this dynamic coefficient of viscosity is given, and you are asked, tau, what is the shear stress at? What is the shear stress at? What is the shear stress at? Let's say zero point 0.5 centimeter, 0.5 centimeter from the plate. Okay, this is 0.5 centimeter from the plate. You will say, that this is very, very easy, sir. We have this du by dy. We'll put this u in this equation. We'll put this u in this equation and we will get the answer. We will get the answer. There is no problem at all. There is no problem at all in doing this question. No problem at all. So what we'll do, we will do like this, sir. We will put this tau is equal to mu du by dy. So we will do what? We will write the equation of this u and we will differentiate it with respect to y, and we will put, so Prakash, there will be 3 lectures. There will be 3 lectures of it in which I'll cover all the topics. I'll try to cover all the topics. So tau is equal to mu du by dy. So we can put this du by dy in this and we can place the value of y is equal to 0.5 centimeter and we will be getting some answer. We will be getting some answer. So that this is very, very easy. This is very, very easy, sir. We can certainly do it. If we know this formula and if we have not solved even one question in life of this, even then we can do it. Say yes or no. Do you believe it or not? Do you believe it or not? Now, I want you to solve this question. Now, I want you to attempt this question, and for every question, we will have 2 minutes. I'll take every question, we will have 2 minutes. Okay? 2 minutes for each question. Okay? So that we can solve as many as question as we can. As many question as we can. So you can see a question. Can we see a question on the screen? Yes, sir, we can see a question on the screen. We can see a question on the screen. So on this question, in this question, I want all of you to attempt in 2 minutes. Those who are light, please attempt it in 2 minutes. Let's see if we can do it. 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 2 minutes. 2 minutes each question. 2 minutes each question. We have to boost our score now. So we have to be very fast in this. We have to be very quick in this. Yes or no? Please keep your calculator, copies, pens handy. Please do it. Please do it. Please try. Please try. So first of all, while you are trying it, I'll tell you a tip also. I usually say this in lectures also. Sir, in GATE examination, question solving has some steps. First step is you must identify the subject. Sometimes what happens, you don't believe me. See, I have been into this teaching profession from last 8 years. Okay, last 8 years. Okay, so from my experience, I tell you, even in the competition, sometimes it also happens that the students are unable to identify the subject also. Sometimes they are not able to identify the subject also. Okay, now first question. If you see this question in your GATE examination, GATE 2021 examination, will you be able to identify that this is a fluid mechanics question? Yes, sir, we'll do that. We are confident enough. We are confident enough on it. Now, once we have understood that this is a fluid mechanics question, the second step, please identify the topic of it. Please identify the topic of it. Okay, sir. Sir, in this, sir, if I read this question, sir, viscosity is given. Viscosity is given, velocity profile they are telling, shear stresses they want us to find, shear stresses they want us to find. So this is a question of Newton law of viscosity. Now, once we judge that this is a question of Newton law of viscosity, just refer your brain. Sir, in Newton law of viscosity, what I have learned in Newton law of viscosity? I had only these 2 formulas. I had only these 2 formulas in mind. Tau is equal to mu du by dy, tau is equal to mu v by y. Now, which formula I can apply in this question? Which formula I can apply in this question? Yes, I am getting some answers also. I am getting some answers also. Very nice. Very nice. Keep attempting. Keep attempting. As much as you attempt, I'll raise the bar. I'll give you more difficult question. So if the velocity profile of a fluid over a plate is parabolic with a vertex of 20 centimeter. Now we all understood that somehow it is going to be in this question, we are going to apply this formula. We are going to apply this formula. We are going to apply this formula. Yes or no? Now in this, yes, Varun. Yes, Varun, good. So in this beta, in this U is not given. Now, if I see this question, and if I see the above question, I'll say the above question is very, very easy. Why? Because in this we have a velocity profile given, we have an equation given, and we simply have placed it into du by dy formula and get my answer. Now, in this question, velocity profile is not there. If velocity profile would be there, I would have easily did du by dy tau is equal to mu du by dy tau is equal to mu du by dy, and we can have our answer. So what is hindering us? What is stopping us from solving this question? That we have no distribution here. In this question, sir, we do not have a distribution. So let's see what distribution, what information they have given. They have given that the profile is parabolic. The profile is parabolic. So profile is parabolic means what? Profile is parabolic means what? Means what? That this is kind of a profile they are having. A parabolic profile they are having, like this, like this, like this. Now I can simply solve this question if I have this velocity distribution available with me. Now they have given me the information that this is a parabolic distribution. So what is the general parabolic equation? What is the general parabolic equation? Ay square plus by, ay square plus by plus c. Is it or isn't it? This is the general parabolic equation, ay square plus by plus c. So this u will become somewhat like this. This u will become somewhat like this if I can somehow find the value of a, b, and c. If I can somehow find the value of a, b, and c. So, sir, how we can find the value of a, b, and c? So, how many constants are there? 3 constants are there, beta. 3 constants are there. So, 3 constants are there. So, we require 3 equations. Isn't it? This is the common understanding. This is the common understanding. Yes or no? Yes or no? That's sir, if we require to find the 3 constant. Yes, beta, Piyush. Okay. Okay. Your answer is somewhat looking like right. Okay. See, getting answer is not important here. Okay. We have to understand this, how we can solve this twisted kind of a question. Okay. So ay square plus by plus c. So we require 3 equations. So for 3 equations, we require some boundary condition in order to make the equations. We require some boundary conditions, sir. So boundary condition, what boundary condition I can use? So sir, what boundary condition we do use in Newton law of viscosity? So these are the boundary condition. At y is equal to 0, the velocity is 0. No, Gurinder. At y is equal to 0, the velocity is 0. This is the first condition. Now, in this question, it is given that the vertex is 20 centimeter. Now, what do we mean by this vertex? Now, this vertex means the top point. So, at this, the velocity is given to be 120 centimeter per second. So, at y is equal to, let's say, 20 centimeter, this velocity is 120 centimeter. And what else? So what is the third boundary condition? Is at y is equal to 20 centimeter, du by dy is equal to 0. At y is equal to 20 centimeter, du by dy is equal to 0. This is the third boundary condition, beta. And let me highlight it. Okay. So if this kind of a question arrive, beta, this score booster session, I have a aim that you will gain something. You will gain something. And in GATE examination, one more thing I want to tell you. In GATE examination, they will pack a question in such a way, that you will be terrified firstly. Okay. If they have to make a question of Bernoulli equation, when we see them in the semester, we have to apply Bernoulli equation at one point, Bernoulli equation at other point, Bernoulli equation at other point. Yes or no? Simply we can do. But in GATE examination, how they will frame it, they will say that some syringe is there. Syringe, if you press the syringe, water will come out. What will be the force on the plunger? When we see that question or a syringe, I have never done the question of a syringe in life. Okay, so will terrify. Okay, so GATE have this tendency to frame a question in such a way that students firstly get some fear out of it, so that they will make mistake. Okay, we don't have to do it. So in this kind of a question beta, in which the velocity profile is not given, what we have understood, what we have gained from this score booster question, that sir, if velocity profile is given, sir, we have no problem. But if velocity profile is not given, we will use this boundary condition. And we can use this boundary condition. Once we will use this boundary condition, beta, y is equal to 0, u is equal to 0, we will get the constant. So c is equal to 0 from equation number 1. If I say this is equation number 1 and I put the boundary condition 1 in it, so c will be 0. Now if I put boundary condition 2, that y is equal to 20 centimeter, u is equal to 120 centimeter per second, 120 centimeters per second. So I can place it there. A y square, that is 20 square, plus b y, that is 20. C is already 0. Now let's say this is equation number 2. Now du by dy. So if I differentiate this equation, du by dy, I'll be getting du by dy is equal to 2ay plus b. Is it or isn't it? Yes, sir. Let's call it equation number 2 in Roman numbers. Equation number 2. So if I put boundary condition in equation number 2 in Roman numbers, so it will be 0, 2a 20 plus b. Now from these two equations, we all have this understanding. That's why from two equations we can certainly calculate two variables. Now we already have the c value. Now a and b we can calculate, and if I place all these values in this equation, I'll be getting an equation like this. And once I can get this equation like this, shear stresses, calculating shear stresses are peanuts, isn't it or not? If we have this kind of equation with us, we'll be able to solve a question, yes or no? So what we have understood from this first question, that whenever velocity profile is not given, we need to use this boundary condition. These boundary condition we need to use. Okay, and once we use this boundary condition, we'll form our equation like this. And once we can form the equation like this, we'll be able to solve it. Is that understood or not? Please tell me if there is a doubt in this. Now, can I mark a tick here? This use of this formula is clear to you? Say yes or no. All of you, say yes or no. The first one. Tell me the first one. Clear or not clear? Please tell me how we can use this first formula. All right. Now coming to this second formula. Of Newton law of viscosity. This is very, very important. Coming to this second formula of Newton law of viscosity. So let us call it type 2 question. Type 2 questions. So in this type 2 questions, we have this formula: tau is equal to mu v by y. Where y is the clearance, and we can use this formula when the velocity profile is either not given. Now see here, if the velocity profile, we can use this formula for linear profiles when we assume the velocity profile to be linear, or in some question if no profile is given at all. If no profile is given at all in the question, if there is no profile at all given in the question, we can assume the profile to be linear and can happily use this formula Now, factor of safety. What is this factor of safety? I mean that what is why mu all of us understand. Now, this is our plate. Let's say this is our plate. So first of all, Newton law of viscosity is a surface phenomena. Now, while we are using this formula, be cautious about what? Be cautious about that this y is the distance from this fixed surface to this surface, which is moving at a velocity v, and this velocity must be in the direction of force, which is causing the shear. So if you want to move this plate with this velocity, there must be some force. Yes, Utsav, I'll definitely share the question. Questions will be shared. Okay. Now, if we move this plate with this velocity, if we apply this force, it will move in with this velocity. So this force will be causing the shear on the surface. Okay. Now the first thing. The force we are talking about. We know the force is shear stress into area. Yes or no? The force is shear stress into area. Getting my point? Okay. Now this force this is the first step of problems we face. This is the first step in which we face the problems. Getting my point or not? Okay, just a moment. Some technical glitches there. All right, all good, I think. Okay. So moving further. So this force, this force is parallel force. Parallel to the surface force. And this area, sir, is surface area. This area is surface area. Okay, my voice is breaking. You are telling. Now, is it clear now? Some technical glitch happened. Now it is clear now. All right. It is clear now. So this is my surface area perpendicular to the plane of paper. Keshav, you are telling me perpendicular to the plane of paper, and this force beta is parallel force. Parallel to what? This force is parallel to the surface. Getting my point or not? Yes or no? Now, keeping that into mind, if we try to solve some question. So this question number two, we can take, we can see. Okay, we can take a reference of this question. So from this question, I want you to understand what is the concept, and how we can use this equation. So we'll do just one part of this question. To save some time. So two large plane surfaces are 2.4 centimeter apart. 2.4 centimeter apart. Okay, so these are, let's say, two large surfaces which is 2.4 centimeter apart. 2.4 centimeter apart. Yes or no? So this is given to be beta. This is 2.4 centimeter. This is 2.4 centimeter. This is 2.4 centimeter. The space between the surface is filled with glycerin, means some fluid is there, and that fluid is glycerin. What force is required to drag a very thin plate of surface area 0.5 square meter? Now, this is what? This is the surface area, beta. This is the surface area. Remember this. This is the surface area. Okay, and the velocity, it is required to move with a velocity of 0.6 meter per second. 0.6 meter per second. Okay, now when we see this question in our GATE examination, we will certainly identify that this is a Newton law of viscosity question. This is a Newton law of viscosity question. Now, this distance, we require this distance. We require this distance because see, this is my y na. This is my y na. So let's call it y1. Okay, and I will also require this distance because this is a surface phenomenon. This is a surface phenomenon. So what we require? What we require? We require distances. We require distances of the fixed surface to the surface which is moving at this velocity. So how many surfaces are there? If you see my hand, there is a surface below, there is a surface upward. So there will be two shear stresses on the top surface. There will be one shear stress on the bottom surface. So how we are going to calculate? So if I say this surface is 1, this surface is 1, tau 1 will be. So what we require? We require a mu, we require a velocity v, we require a gap y1. We require this gap y1. See, what I am trying to tell you, using this formula, we require the velocity, we require the distance, so Venkat, your question is not visible, beta. Let me increase the size of it. Then just wait a minute. Just wait a minute. Okay, clear now? Clear now? All right. So what we require, we require this velocity, we require this distance, and we can apply this formula. Now, can we find this tau 1? Can we find this tau 1? Can we find this tau 2? Can we find this tau 2? Yes, sir. We can find this tau 2. We can find this tau 2. Getting my point or not? Or sir, you are giving me some answer? You are giving me some answer, but that answer I don't think it is correct. So we can have this tau 1, we can have this tau 2. We can have this tau 1, we can have this tau 2. Getting my point or not? Now this tau 1, do we have mu given in the question? Yes, sir, mu is there in the question. We can place the value of this mu. We can place the value of this mu. Getting my point or not? We can place the value of this mu. Okay. So this 10 to the power minus 10 is not there. Okay. It is, I think, miswritten. Okay, so this is 8.1. This is 8.1. This is mu is given to us 8.1. This velocity is given to us 0.6. This distance we can calculate. So they are saying that the thin plate is in the middle of two plane surfaces. So this will be 1.2. This will be 1.2. So we can have our tau 1. We can have our tau 1. Similarly, sir, we can have our tau 2 as well. We can have our tau 2 as well. In the first part, because the distance, the plate is placed in the middle. So this distance is 1.2, this distance is 1.2, this distance is 1.2 as well, this distance is 1.2 as well. Okay, so we can have this shear stresses, we can find this shear stresses. Now coming to force, what we can do, we can multiply the surface area to each of the shear stresses, and we can get our answer. Is that clear or not? Is that clear or not? Yes or no? Area, remember the surface area. So 2 points in this equation, in this formula, beta. In this formula, two important points I mentioned. Two important point I mentioned. So from this tau, whenever we are getting this force, that is tau is equal to. So if we have the shear stress, all of us know if we have the shear stress, all of us know that's the shear stress. From shear stress, we can calculate from shear stress, we can calculate the force, that is tau into A, shear stress into area. Now the important point I want you to understand, that this force is parallel to the plate. This force is parallel to the plate. This force is parallel to the plate. So if we calculate this tau 1, if we calculate this tau 2, and if we put them in this, what force we are getting? What force we are getting? Please tell me, what is the force that we are getting? What is the force that we are getting? Can you please tell me what is the force that we are getting? Please tell me what is the force that we are getting? Anyone? So some answers are coming. Some answers are coming. Some answers are coming. So, so we are getting 405 Newton. 405 Newton. Is it or isn't it? We are getting this 405 Newton. Yes or no? Yes or no? If just placing all this value, we will be getting 405 Newton. Okay, so what I am trying to tell you, beta, what I am trying to tell you, always remember that the force that is acting is parallel to the plate, is parallel to the plate, is parallel to the surface, is parallel to the surface, is parallel to the surface. Also the velocity is also parallel. So in applying this formula, now where will you apply this second formula? When no profile is given, as we have seen in this question. Any profile was given in this question? Any profile was given? No sir, no profile was given. No profile was given in this question. Yes or no? No profile was given in this question. So no profile, when no profile was given in the question, we can assume if no profile is given in the question, we can assume the profile to be linear, and then we can apply the formula like this. Then we can apply the formulas like this. Getting my point or not? Getting my point or not? Getting my point or not? Now if you see the kind of gate question that got asked in this, so you can see a PowerPoint presentation, a PowerPoint page on your screen. Yes or no? We can see a PowerPoint page on the screen. So this kind of a question, this is a gate question. This is a gate question. So in this, what is given? In this question, 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 it is given, sir, incompressible fluid, kinematic viscosity is given. Kinematic viscosity is given. So this kinematic viscosity is what? This kinematic viscosity is what? This kinematic viscosity nu is equal to mu by rho. We know it. Dynamic viscosity by rho. Yes or no? Yes or no? Is held between two parallel plates. Almost same question. If the top plate is moved with a velocity of 0.5 meter per second while the bottom one is held stationary, the fluid attains a linear velocity in the gap of 0.5 mm. 0.5 mm between these plates. A linear velocity profile in the gap of 0.5 mm between these plates. The shear stress in Pascal on the surface of the top of plate. You will say, sir, this is a very easy question, sir. We have no. Firstly, we will identify this is a fluid mechanics question. And once we identify this is a fluid mechanics question, since no profile is given, we have this formula only. So do we have the velocity? Yes, sir, we have the velocity. Do we have that viscosity? Yes, sir, we have kinematic viscosity. We can get. Yes, Frozen, I'm coming to that. Okay, so mu is our, we can find our mu. We have this y, sir. We have this y, sir. So certainly, sir, I'll be able to solve this question. Certainly, I'll be able to solve this question. Say yes or no. Say yes or no, sir. Yes, sir. Yes, sir. Will be able to solve this question. Similar question. Similar question. Getting my point. Where to apply this formula, sir? Where to apply this formula, sir? Is that clear? Can I place a tick here? Can I place a tick here, beta? Can I place a tick here? Tell me. Can I place a tick here? Say yes or no. Say yes or no. All of you. See, I told you in this session, we are trying to understand the concept as well as the question. Okay, okay. Not necessary we always require to find the value. Not necessary we always require to find the numerical value of it. The numerical value of it. Getting my point or not? Getting my point or not? Getting my point or not? Yes or no? Yes or no? So can I place a tick in it? Yes, sir. Yes, sir. Now, in this question, in the second part of this question, what is given? The thin plate is at a distance of 0.8 centimeter from one of the plane surface. Now, if it is 2.4, if it is 2.4 and it is 0.8, it is 0.8, what it will be? It will be 1.6, it will be 1.6. So only thing that will change, it will be y. It will be this gap. It will be this clearance. Is that understood or not? Is that understood or not? Is that understood or not? Now, if I see question number 3, now this is one more variation which is very frequently getting asked in the GATE examination. In the GATE examination, if I see this kind of a question, we do not need to solve it. We need not to solve it. Let's try to understand the concept. Now, in this question is also from machine design. So a 15 centimeter diameter vertical cylinder rotates concentrically inside another cylinder of diameter 15.1 centimeter. Of diameter 15.1 centimeter. So see, there is a cylinder. This can be a bearing also. Sometimes it may be called upon as a bearing as well. So here it is a bearing. Here it is a bearing or a cylinder. In this, there is another cylinder. There is another cylinder. So this is a vertical case, but we can assume it to be horizontal. That doesn't matter. This 25 centimeter high means this is the length. This is 25 centimeter. Length, it is 25 centimeter. The space between the cylinder is filled with liquid whose viscosity is unknown. So some liquid is there, but viscosity we do not know. Viscosity we do not know. Now in this torque is given. The torque is given to rotate the inner cylinder at 100 rpm, and we require to find the viscosity. Yeah, it is combined machine design and FM. Yeah, right, Mahendra. So if a torque is given, beta, and we are required to find the viscosity, so somehow we are going to apply this formula. Yes or no? Somewhat we are going to apply this formula. Now to apply this formula, we require this torque, we require this tau, the shear stress. So this torque is F into R, force into radius, yes or no? We know it. Now from this we can get our force, and from force we can get our tau. From force we can get our tau. Now factor of safety. Now what kind of a mistake students do here? Now whenever we see some cylinder, whenever we see some circular thing, we are very much tempted to use this formula, pi by 4 d square. We are very much tempted to use this formula. Yes or no? Pi by 4 d square, and let me increase a little bit size of it. Let me increase a bit of size of it so that all of you can suitably see it. So this is pi by 4 d square. So we are very much tempted to use. Vijay, this is very, very applicable to civil engineering also. This is very much applicable to civil engineering also. In civil examination, some questions are getting asked from Newton law of viscosity. Okay. Whatever I am teaching here is applicable for both civil and mechanical. So never apply this formula, pi by 4 d square. This is very much applicable to civil. Getting my point or not? Vinay, you are saying, sir, what happens if we apply drag force? So if we apply drag force, this is what we call as the drag force only. This is what a drag force, because this viscosity is going to offer some resistance to your flow. So this is your drag force only. This is your drag force only. Now coming back to this, so never apply this formula, because sir, I told you what this area is, surface area. This area is surface area. So surface area of a cylinder is pi dl. So first mistake can happen here. First mistake can happen here. First mistake. We'll come back to the last question then. We'll come back to the last question then. So this is pi dl. This is pi dl. This is pi dl. Okay. So this is by surface area. This is by surface area in this. This is my surface area in this. So never make a mistake here. Never make a mistake here. Always use surface area. So from here you can get your tau. From here you can get your tau. And since no velocity profile is given, no velocity profile is given, I can replace this du by dy with v by y. With v by y. Now what is this v? Now what is this v? This v is a surface velocity. This v is a surface velocity. So this velocity, if I can find this velocity, so what is this velocity? This velocity is pi dn by 60. This is the surface velocity, na? Pi dn by 60, say yes or no? This is the surface velocity, na? This is the surface velocity, na? Yes or no? Yes or no? Yes or no? Since RPM is given in the question, RPM is given in the question. Now, once we get this surface velocity, for calculating F, sir, so this torque is on the inner cylinder, na beta. So this is the radius of shaft. This is the radius of shaft or inner cylinder. The one which is rotating, beta. The one which is rotating. Getting my point or not? Now, this is the surface velocity. We have obtained the surface velocity. Now, what else we require? We require this y. We require this y. Yes or no? We require this distance y. We require this distance y. Getting my point or not? Getting my point or not? Now, once we have this y, so we can place all this, and tau we have found from here. Tau we can find from here. V we can find from using pi dn by 60 formula. Y is, now this is given to be 15.10. This is given to be 15. This is given to be 15. This is given to be 15. So can we find this gap? Yes, sir. This gap is 0.05 then. 0.1 by 2. This gap is 0.05 centimeter. 0.05 centimeter. And sir, I'll take care of the units. I'll place all these values here and we'll get the value of mu. We'll get the value of mu. Is that clear or not? How to use this formula, beta? How to use this formula? Is this clear or not? How to use this formula? Is this clear or not? Is this clear or not? Please tell me. Is this clear or not? 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 All right. All right. Now coming to Vinay. Vinay, you asked me, sir, in the last question you had some doubt. In the last question, Vinay, you had some doubt. Now you have written, sir, what happened if we apply drag force is equal to integral T W dA. So this T I assume to be tau, and W is what? W is what, beta? W is what? Now, if I ask you what is a force, what is the difference between a force and the stress, beta? Okay, this is wall shear stress, beta. Right? So this force we are talking about, this force, how we can define a shear stress? So shear stress is integral force, parallel force per unit area. Is it or isn't it? So if we talk about integral, this drag force is nothing but the integration of this. My dear, you see how we can define some stress. How we can define some stress? Stress can be defined this way. Yes or no? F by A. Yes or no? Now this is something which is coming from the definition of this differentiation. So we can replace this like dF by dA. df by dA. So this df is equal to integration sigma dA only. Yes or no? Yes or no? Yes or no? So if I place it as shear stress, if I say this is a shear stress, so if we integrate it, the drag force, not the drag force, but any force is integrated shear stress, integrated stress. Got my point or not? Got my point or not? Yes or no? Now coming to this, beta, coming back to this. Now this formula, use of this formula, I hope is understood to all of you. Now in this first topic, the numericals are mostly, if you see the gate question, the previous year gate question, if you see beta the previous year gate questions, you will be seeing questions like them. Many questions you can see like it. Like this question, beta. This is the same question. Only. What is this written? In a simple concentric shaft bearing arrangement. Shaft hai, there is a shaft, there is a bearing. The lubricant, there is some lubricant. Gap is there. Okay, gap is there. The diameter is there. Speed is there. Tangential speed is there. Viscosity, dynamic viscosity is there. Now you have to calculate the force. So can we do it the same way as we have done the previous question? No need of solving it. We have a lot to cover. In 6 hours, I want to boost. And at the GATE Academy, we try to boost your score. Okay. We'll do the questions. We'll have all these questions. We can attempt them. Whenever we want. Okay. Now the thing is, we need to understand the concept well. How to use the formula, which formula to be used. This is something which is very important. So, are you confident enough that sir, you can solve this question? Are we confident enough or not? Please tell me that. In this question, are we confident enough or not? Yes, sir, we are confident enough. Yes or no? Please tell me. Now, moving ahead in this first chapter, properties of fluid. What else formula we see? What other formula we see? So we see bulk modulus compressibility. So I have written it in blue because these numericals are not getting that frequently asked as compared to Newton law of viscosity. So whenever you see some formula written in red in this sheet, just consider that to be very important. Getting my point? Now this bulk modulus formula is dP upon minus dV by V. Okay, this is what we have learned. dP upon dV by V. So we have to memorize, we can memorize this formula. So if we write it in terms of density, as well, we can have this relation, which have, yes, Dinesh Kumar, definitely I'll provide the answers. I'll see this question sheet will be provided to you. And in that question sheet, I will mention the answer of all the questions. In this session, I'll solve them and I will give you the sheet. Will that be fine? Beta? But in this session, what we are trying to do, if we do the question, now you assume that, sir, if a question you will take 2-3 minutes to solve it. Many of you will give me the wrong answer. Some will give me the right answer. Okay. So I want to utilize at the GATE Academy, we want to utilize as much as time as possible. Okay. Because since it is already 6th December, today is 6th December, our GATE is like on our doors. Okay. So we cannot afford to waste time. Okay. That's why we are not going to waste your time as well. So I'll provide all, you just answer, all of you just have to tell me whether you will be able to do it or not. And in some question, if you want to, if I feel that attempting is required, I'll hold. Okay. Or if you say that, sir, in this we want to attempt right now, then we'll do. Fine enough? Fair enough? Yes or no? Fair enough. Now coming to this bulk modulus formula. Now if a pressure difference, this dP is what? Pressure difference. If two pressure is given and change in densities, etc. is given, you can apply all that in the question or not? You will be able to apply those in the questions or not? I believe yes. So if we memorize this formula, so see how I have written this thing. So in the properties of fluid, first and foremost important thing, Newton law of viscosity. Then what else formulas are there? So that we can quickly go through it. We can quickly revise it. a day or 2 days before examination. And in this formula, dp upon dv by v, dp upon d rho by rho, dp upon d rho by rho. So in this formula, if everything is given, I assume all of you can place the values in the question and find the answer. Find the answer. And this compressibility is reciprocal of bulk modulus. This compressibility is reciprocal of this bulk modulus. So can we mark a tick here? Can we mark tick here? That's that if all the required data is given in the question, we'll be able to solve these problems. Yes or no? We'll be able to solve this problem. Yes or no? Yes or no? Okay. Now, the other thing that is getting asked from this first topic, from this first chapter, is excess pressure intensity. Excess pressure intensity, which is a surface tension concept. Quick revision, quick revision, quick revision. Okay, quick revision. And meanwhile, please also do subscribe and like the GATE Academy also. Na? Okay, we are giving you so many good conceptual videos, study videos. Yes or no? Okay, so please do like, subscribe, share with your friends also. If you like this session, please bring your friends also in the live sessions. Okay, okay. So this excess pressure intensity, this is surface tension concept. This is surface tension concept. Okay. So sigma is what? Sigma is surface tension, force per unit length, force per unit length, force per unit length. This is our surface tension. This is our surface tension. Now some question you can see directly question. What is the pressure intensity inside a liquid droplet? Inside a water droplet or any liquid droplet. So that pressure intensity, for that we can have this formula. We can use this formula. Very simple formula. Del P is equal to 2 sigma by R. Del P is equal to 2 sigma by R. Yes, Dinesh Kumar, surface tension can also be defined in terms of energy per unit surface area. Getting my point? Now, this soap bubble, sometimes they ask that what is the pressure intensity in a soap bubble. For soap bubble, it is 4 sigma by R. For soap bubble, it is 4 sigma by R. Sometimes never ask this. They never ask this liquid jet. But for mentioning, I have written it here. So this delta P is sigma by R. Now, what is to take care of? That this intensity, this pressure intensity, excess pressure intensity is gauge pressure. This excess pressure intensity is gauge pressure. Getting my point or not? So we are going to get gauge pressure from it. Gauge pressure from it. Okay. Gauge pressure from it. So all these formula, if we remember, if some question is given, surface tension is given, radius or diameter of the droplet is given, are we confident enough, sir, that we will be able to find this or not? Are we confident enough? Yes, sir. Do we need to solve a question of it in a score booster? A score booster means which can help you solve some difficult question, some different kind of a question. Getting my point? Some conceptual question. Yes or no? Now in this soap bubble, if sigma is given, if R is given, sir, definitely we'll be able to put the values and get the answer. Is it or isn't it, beta? Is it or isn't it? Tell me. Keep telling me, beta. So, Shahrukh, sir, a soap bubble inside a water will have the, what do we mean by inside the water, beta? What do we mean by inside the water? Okay. So soap bubble, see, soap bubble is like we assume there to be two surfaces. We assume it to have two surfaces. Okay. That is why this formula is coming. That is why this formula is coming. So if they call it as a water bubble, if you are talking like that, it is a water bubble. So water bubble is nothing but water droplet kind of a thing. Okay, there is no bubble then. It is a droplet. Yes or no? Yes or no? Water droplet. Okay. Okay. Now in this pressure intensity, we'll be able to calculate quickly by using this formula. Now the last formula, last numerical from where numerical can be asked is the concept of capillarity. Now in this capillarity, again we require to use this surface tension. This theta is there. This R is what? R is the radius of the tube. R is the radius of this tube. Okay. So if all the necessary data is given, can we find this H? And it is same for same for both rise and fall. It is same for both rise and fall. It is same for both rise and fall. So can we say, sir, we have quickly revised all the formulas from where numericals can be asked from this properties of fluid is clear to us? Say yes or no. Is clear to us? Is clear to us? Is clear to us? Tell me. Is clear to us or not? Is clear to us or not? Newton law of viscosity and all these formula. If a question will arrive, will you be able to solve it? Will you be able to put the values of sigma, theta, r and all? And this theta value for water and mercury, you must remember. You must remember. Getting my point or not? Getting my point or not? Yes or no? Getting my point or not? All right. All right. Now coming to the next chapter of fluid statics. Now first topic revision, quick score boosting is completed. Yes or no? Quick score boosting is completed. We have seen some questions. We have quickly revised all the necessary formulas in this first topic from where question can be asked. Now coming to this pressure and its measurement topic. Coming to this pressure and its measurement topic, the topic number two. So in this topic, there is no such formula at all. There is no such formula, just one hydrostatic law. There is just one hydrostatic law. So in this hydrostatic law, this is P is equal to rho gh. The first formula, P is equal to rho gh. We all know it. Do we or don't we? Pressure depends upon height only. It doesn't change with x and y. That means it doesn't change with horizontal direction. So what I say, I am talking with this coordinate system, x, z, and y. X, z, and y. So from hydrostatic law, we have only this formula, P is equal to rho gh. So this is something. Very, very important. P is equal to rho gh. We can find if we have the value of this h. We can have pressure at some point. This is the first thing. Now the second thing. This formula. This is not a formula, but an understanding. What is the understanding? That for a given pressure, very importantly, for a given pressure, we can use this relation. So for some pressure, for some p, we can use this. Since we can see how many fluids there in the world. There are infinite number of fluids. So whatever fluid density I'll place here, I will be getting a different H. If I place the density of water, my H will be different. If I place the density of mercury, my H will be different. If I place density of something else, my H will be different. Getting my point or not? Yes or no? Getting my point or not? Okay. So for all this, we can write this as S1, H1, S2, H2, S3, H3, where S is specific gravity. Where is what is my S? S is specific gravity. Is specific gravity. Now if I want to equate it like this, SWHW means is specific gravity of water and specific and height of water. Will be able to do it, yes or no? Yes, sir. But sir, specific gravity of water is one only. So if I want to replace, see what is the use of this formula? Very useful thing, very useful concept. So if we have a container like this, and in this container, let's say some liquid. Now try to understand the concept behind it. Now in this container, some liquid is there which is filled to a height of let's say 0.5 meter, and this is some oil. With a specific gravity of zero point 0.8. This is the oil with a specific gravity of 0.8. Now I want to replace this oil for the same pressure at the bottom. I want to replace this oil for the same pressure to water, for same pressure to water. So what I have to do, I just have to write like this: zero point 0.8 into 0.5, 0.8 into 0.5, 0.8 into 0.5. So it will be 0.4, it will be 0.4 meter, it will be 0.4 meter. So it means if I want to change this liquid into water, if I want to change this liquid into water, it will be filled up to a height of, it will be filled up to a height of 0.4 meter. It will be filled up to a height of 0.4 meter. Is that clear or not? Is that clear or not? Yes or no? Simply, we can change any liquid into terms of water just by multiplying up to what height that liquid is there and what is the specific gravity of that liquid. What is the specific gravity of the liquid? Now, coming back to this formula sheet, now these two concepts, P is equal to rho GH, and changing everything to water, S1 H1 is equal to S2 S2 is equal to H3 H3. So we can equate like this. Now we see so many manometer problems in our fluid mechanics. So many manometer problems we do see in our fluid mechanics. Okay, so in order to solve the manometer problem, these are some points I have mentioned that needed to be used while solving a manometer problem, and you can quickly solve a manometer problem then. So points to remember: so change everything to water. First of all, you need to change everything to water. Sab kuch, everything to water. Whatever is given in the question, change it to water. Okay. Whenever we are moving downwards from hydrostatic law, whenever we are moving downwards, we need to add the pressure, and whenever we are moving upward, we need to subtract it. Now, using these equations, using these formulas, we can solve some questions. So let's copy this question. Let's copy it here. Okay. Now, this is the question. This is some question. This is one question on your screen. Now, I want all of you to attempt it. This question. Can we attempt this question? Can we solve this question? Let's see if we can solve this question. It says YouTube manometer. Let's see if we can solve this question. You have to give me the answer of this question. You please solve it and give me the answer to this question. Let's see if we can do it. Let's see if we can do it. Dinesh Kumar, you are giving me some answer. What about others? What about the others? What about the others? What about the others? What about the others? So how we can do it? How we can do this question? So what we have understood, beta? What we have understood? Change everything to water. So I do not want to know what is flowing inside this pipe, but whatever may be flowing, I can write that pressure in terms of water. So this is HAW. If I write this equal to HAW, whatever may be the pressure, we may write it as HAW. Now we are moving upwards from this point. So what we have understood, what is our important point? If we are moving upwards, just subtract. Just do the subtraction. Simply just do the subtraction. So I have written this minus. I have written this minus. I have written this minus. So we have moved upward by the distance of 1 meter. And let's follow the procedure we used to do SH, specific gravity into height. So if this is water, let's multiply it with 1 also. Okay. Now from this point, if we see from this point, to this point, we are moving the same distance up and down. We are moving the same distance up and down. We are moving the same distance up and down. So nothing is required to be mentioned, because when we move this much up, this will be subtracted, and when we move this much down, this will be added. So ultimately it is going to get cancelled out. So we have reached this till this point. Now similarly from this point to this point, the amount by which we are moving downward and the amount by which we are moving upward, both are same only. So the same thing is getting added and then subtracted. So we need not to write anything in this portion as well. Now we have reached till this point. Yes or no? We have reached till this point. Now from this point, I am moving upward. From this point, I am moving upward. So from this point, if I am moving upward, how much I am moving? I am moving 0.6, and I am moving in mercury. So the density of mercury is 13.6. So we have reached till this point. Okay. Now from this point to this point, there is water again. So we need not to write anything. Yes or no? We need not to write anything. All right. Now we have reached till this point. Now we are moving downward. In what? So if we are moving downward, we need to add. So we are moving downward in water, and we reach to this point. B. So whatever may be the pressure at this B, let's write it to be HBW. Yes or no? Now from here, can we calculate our HAW minus HBW? Tell me. Can we write this HAW minus HBW? Please tell me, what is this HAW minus HBW? Please tell me, what is HAW minus HBW? Can we calculate it? Yes, sir. Certainly we can. Venkat, we will see some MSQ questions. Getting my point? We'll see some. Okay, so Rahul, I'll repeat. No worries. I'll repeat. Okay. So first of all, do we all understood the concept? How to solve a manometer question? So in order to solve a manometer question, the first important tip: change everything to water. Second important tip: when you are moving upwards, you need to subtract. Third, whenever you are moving downwards, you need to add. Is this clear or not? Okay. Answer how to change from something to water. So we simply multiply specific gravity into height. You multiply specific gravity to height, it will be changed to water. Now from this A point, all we have to do is we have to flow with the liquid. So just consider yourself flowing with the liquid from A to B. Now once you start to flow from A, let's write whatever is the pressure at this A point, let's call it HAW. Now from this A, we are moving upward. So if we are moving upward, do we have to subtract? And we have moved upward to this point, this red. color mark. Okay, so we have moved this to this point. So we have moved 1 meter. We have moved 1 meter and we have moved in water. So to follow the procedure, let's do S into H everywhere. Let's do specific gravity into height everywhere. Okay, okay, because we need to simplify the thing. So we just did 1 into H. Now if you see, if I move, let's say, let's call it Y. Let's call it Y. So if I am moving upward, I shall write 1 into Y, specific gravity of water, into Y. We have reached this point. Okay, we have reached this point. Okay, now the same way, when we reach this point, we are moving downward. So we need to add, so this will be 1 into Y. This will be 1 into Y. So it will be cancelled out. So it is not required to be written. Okay, so the tip is, whenever we are moving the same distance above and below, same distance upward and downward in the same liquid, we need not to write anything. We need not to write anything. Understood or not? Understood or not? So this is minus 1 into 1. This is minus 1 into 1. Okay, this is minus 1 into 1. So we have at this point. Now from this point to this point, we need not to write anything. Now you see, just follow the highlighter. Just follow this highlighter. Now from this point to this point, are we moving the same distance in the same liquid? Downward and upward, are we moving the same distance in the same liquid, downward and upward? You will say yes, sir. You will say yes, sir. So do we require to write anything? No, sir. We do not require to write anything. Now we have reached to this point. We have reached this point. Now from this point, are we moving upward? Yes, sir. So we are moving upward. So we need to subtract, sir. We need to subtract, sir. So we are required to subtract. So I am putting minus. So how much we are moving? We are moving into 0.6. And what is in which we are moving? We are moving in mercury. So that is 13.6. That is 13.6. That is 13.6. So we have reached this point. We have reached this point. Now from this point to this point, we are moving in water by the same distance. By the same distances, we are moving in water. Okay, so we need not to write anything. We need not to write anything. Now from this point, we are moving downwards. So we are moving downwards. So we must add, and we are moving in water. So we must do 1.6 into 1. And we have reached this B point. So we must write HBW. We must write HBW. Getting my point or not? Rahul, you asked me to repeat, so I repeated. Now from here, can we get HAW minus HBW, all of you? Can we get HAW minus HBW, please? Can we get HAW minus HBW, please? So this is 1.6, 13.6 into 0.6. plus 1 minus 1.6. So it is going to be 7.56 meter. It is going to be with a 7 point. It is coming out to be 7.56 meters. 7.56 meter. Now I need to convert it into Pascal, Newton per meter square. So how we will convert? So we will apply this formula for conversion. What formula we need to apply? We need to apply this P is equal to rho GH formula. P is equal to rho GH formula. So let's convert it back. So P is equal to rho GH. So we need to convert it into pressure. So always remember, if you are doing this way, always use the density of water. So rho is 1000 into 9.81 into 7.56. So you will be getting Newton per meter square. You will be getting Newton per meter square. So how much we are getting, beta? How much we are getting? We are getting this 74 kilopascal. We are getting it equal to 74.16 kilopascal. So what is the answer to this question? 74.16 kilopascal. Now initially Vijay, Dinesh, you both have given me the wrong answers, beta. Now is it understood or not? Is it understood or not? Please tell me. Now I want all of you to write, find the pressure. Let's do it this way. Okay. Now see, in a manometer problem, what we can say, sir? In a manometer problem, sir, in a manometer problem, sir, all we require, see, this is the logic, this is the concept, score booster concept, you can call it. Score booster concept, beta. Score booster concept. See, whatever manometer is there, generally in GATE examination, we can see question, simple questions, YouTube manometer, inverted YouTube manometer. But see, when they make it like this, if we can make it like this, if they make it like this, okay, don't be afraid of it. You just have to follow the procedure. What is the procedure? Change everything to water. Change every single thing to water. Whenever moving downward, add. Whenever moving upward, subtract. Whenever moving upward, subtract. Okay, so this is the formula sheet. In this formula sheet, I have mentioned it. Okay, see, only these things to be used in this topic. Only this thing is to be used. Pressure is measurement. You can solve hundreds of questions. And those who have studying in the GATE Academy, who have studied from me in the GATE Academy, they know this method very well. Okay, so you can solve hundreds of questions from it. Getting my point? Only thing required is these three lines. Okay, change everything to water, moving downward, add, moving upward, subtract. Now let's just quickly write the pressure for this A. I need to find the pressure for this A. We need to find the pressure at A in Newton meter square. So I need this pressure in Pascal. Okay. So can you do it? Beta? Can you do it the same way? Please try. Do it the same way. If we can solve this problem, I can hope that we can solve all other problems as well. Usab, sometimes every faculty have his way of teaching. Yes or no? So that is why this food booster session is there, beta. So that we can understand this concept. Whole topic, whole pressure measurement will be completed in 3 lines only. 3 lines. Okay, change everything to water. How to change, I told you. Okay, moving downwards, add, moving upwards, subtract, beta. That is all. Do this question. Do this one. Vinay, we do not require this actually. You just write the equation in terms of H and S. Deliberately, I have not given the values of H and S here. Okay, because we are finding, I told you guys now, GATE have this tendency to pack the question in a way that we may have the fear of it. And we all as a student, I am also currently a student of IIT Roorkee. I am a PhD scholar. Okay, although I am almost submitting my PhD. Okay, but still I am a student for time being, isn't it? So I understand it well. Okay, so whenever we see this values, this variable S, H, this, that, then we'll be in trouble. Okay, when we see the beautiful value like 0.8, 0.7, we'll be very happy. Okay, but here we need not to be happy. Okay, here we are not supposed to be happy. Okay, we need to secure marks in the GATE examination. Yes or no? Okay, just solve this now. And please ask your friends to come in live sessions. Okay, this score booster session will definitely help you. In 2 hours, whole statics I'll make you revise. Whole properties of fluid has been revised. Some questions go through quickly. We have gone through. Similarly, this pressure and its measurement we quickly have gone through. Okay, So just do not miss the score booster sessions. Whole subject, whole fluid mechanics will be revised quickly. And although since it is a score booster session, we cannot dip into the concept. Okay, for that, please subscribe the GATE Academy channel. Please subscribe our channel, the GATE Academy English channel. We have a Hindi channel also. Okay, All right, we have this Hindi channel also. So all we can do, we can subscribe. We have good videos of fluid mechanics and each and every subjects there, so we can refer them. We can refer them. So in the same Piyush, you have given me the answer, beta. Very nice. Okay, just attempt. Now, if I want to write it now for conceptual clarity, I have framed this. Now from A, change everything to water. I do not want to know what is flowing inside it. I do not want to know what is flowing inside it. But whatever may be flowing inside it, beta, whatever may be flowing inside it, I can write it in terms of head of water. I can write it in terms of head of water. So it will be HAW. Now moving in this direction. Now with this black pen, I'll move with this black pen. We are moving in this direction. Shall I write anything? No, because pressure do not change in this direction. So nothing to be written. We have reached till this point. Now from this point, we are moving downward. We are moving downward. So shall I add? Yes, sir. Yes, sir. Our concept is we shall add when we move downward. So it will be S1H1. Change everything to water. So it will be S1H1. We have reached till this point. We have reached till this point. Now from this point to this point, we are moving in the same fluid. Do we require to add anything? Do we require to add anything? No, sir. No, sir. We do not require to add or subtract anything. We do not require to write anything. We have reached till this point. We are moving upwards, sir. So we are moving upwards. So we need to subtract. So we are moving in S2 fluid by a distance of H2. So simply S2, H2. Now we have reached till this point. We have reached to this point. Now from this point to this point, we are moving in the same fluid. From this point to this point, we are moving in the same fluid. From this point to this point, we are moving in the same fluid. So anything to be written? No, sir, nothing to be written. Now we have reached till this point. We have reached to this point. Now from this point, we are moving downward. We are moving downward. So if we are moving downward, shall I add or not? Shall I add or not? Yes, sir. We shall add, sir. We shall add, sir. So S3H3, we shall add, sir. S3H3. Now from this point to this point, from this point to this point, we are moving in the same fluid. Do we need to do we need to make, do we need to do anything? Do we need to do anything? No, sir, we need not to do anything. We have reached till this point. We are moving upward. Now subtract. Simply S4, H4, H4, H4. That is why you serve. We are making this manometer simple. Okay, that is why I am asking, please do not miss the score booster session. Okay, now we have reached this point, S4, H4. Now from this point to this point, from this point to this point, shall we write anything? No, sir, nothing to be written, sir. No required to, nothing is required to written. Okay, nothing we required to write. We have moved, we have reached till this point. Now from this, we are moving downward. So shall we add, sir? Shall we add, sir? Yes, sir, we shall add, sir. We are moving by H5, include S5, just simply S5, H5. Peanuts. Okay. Now we have reached this point. We have reached this point. Now from this point to this point, do we need to add anything? No, sir. No, sir, because we are moving in the same fluid, sir. So whenever we are moving in the same fluid, nothing is required to be written. Yes or no? Now we have reached till this point. We have reached till this point. Now from this point, we are moving upwards, sir. We are moving upwards, sir. So upward we are moving. So we need to subtract, sir, S6, S6. And since it is open to atmosphere, we can equate it with 0. Why 0? Because from manometers, we are finding the gauge pressure. If we are equating it with 0, if we are equating it with 0, that means this pressure will come out to be gauge. Now you tell me, sir, Vinay, you were asking me the values. If values would be given, would you be able to place it and give me a beautiful value of HAW or not? Say yes or no. If values are given, will you be able to, or will all of us be able to solve this HAW or not? Please tell me. Please tell me, everyone. Please tell me, everyone. Will we be able to do it? Yes, sir. Yes, sir. Yes, sir. We'll be able to do it. And if I place the values of H in meter, I'll be getting it meter. Okay. Now I have to convert. When I have to convert it in pressure, always remember to use rho GH. Always remember to rho GH. And what is the factor of safety? This is always 1000. Whenever you are using this method, we get confused sometimes that, sir, if this is given to be 0.8, sir, shall we use 800 here? No, because we have converted into water. We have converted into water. So we are writing we are writing if had in terms of water, we need to use the density of water only. We need to use the density of water only. Got my point or not? So always in this method, always rho is equal to 1000. So if you are using this method, please remember to use always the density equal to 1000. Now please tell me, can I place a tick here? Can I place a tick on this, on these? This pressure and its measurement is cleared. These two chapters are completed of fluid mechanics within 1.5 hours. Because for first 10 minutes I just introduced myself, so I'm reducing that, excluding that. In 1.5 hours we have almost quickly revised. Not, we can never say complete. Okay, see, fluid mechanics is this much. You cannot see my hand in the screen. I can say this is this much. I know this much. Getting my point? In GATE it comes this much. Getting my point? Getting my point? Okay, so we all require to this information. So this could be helping you in a quick revision. We are no way claiming that this can be a substitute. This can be a substitute of our classroom teaching. Getting my point? Okay, in classroom, in our live sessions, we tell all the things in very detail. But for a quick succession, quick revision, quick remembering of concept, how to attempt the question, okay, for that this score booster session is. Getting my point? So can we say quickly that we have pressure and measurement is completed? Now the third topic of this fluid statics is hydrostatic force on surface. In this hydrostatic force on surface, the hydrostatic force on surface, we have this one formula. We have this very important one formula, that is total pressure. Total pressure rho g ax bar, rho g ax bar, and the other one is center of pressure. The other one is beta center of pressure. Center of pressure. Okay, so this center of pressure we will denote by h bar, and its formula is ig by ax bar sine squared theta plus x bar, plus x bar. So these are two very important formulas of this topic. If you see a question, of this hydrostatic force in GATE examination, these two formulas are highly utilized, highly useful, highly useful. Now, can you tell me what is the unit of this total pressure? What is the unit of this total pressure? Can somebody please tell me what is the unit of this total pressure? What is this unit of this total pressure? Anyone? Any beta? Anyone beta? Anyone beta? Now remember this beta. This unit is Newton, not Pascal or Newton per meter square. Some people will be confused. Sir, it is written to be pressure, sir. Pressure is Newton per meter square, sir. No, there is nothing like total pressure means what? Total pressure means the force only. Total pressure. See, two words never use. Total pressure, total stress. In these two words never exist. Okay. Okay. Stresses and pressures both are at a point. Both are at point. So when you integrate them, Vinay, you were asking me this previously also. When we integrate them, we get the force. So total pressure, or somebody, if some will say total stress, it's nothing but the force only. Nothing but the force only. So this total, that is why I deliberately written here total pressure. So this total pressure is this hydrostatic force. So you can see it by many names. You can see it by many names. You can see it by many names like total pressure, hydrostatic force, total hydrostatic force, total pressure force, but all are same only. All are same only. That is rho a g x bar. Rho a g x bar. Okay, where beta this x bar is vertical distance of centroid of surface taken from the surface of the fluid, taken from surface of the fluid. Now to explain this concept, I have taken a simple question. I will solve the simple question, then you will solve the next question. Okay, simple question for me, tough questions for you beta. Yes, Mahinder, as I told you, if they are writing total pressure only, that is also a force. That is also a force. So sometimes in some books, you will see only total pressure and we get confused. We get confused. So they are asking total pressure and calculating something which is having a unit of Newton. So that total pressure is nothing but beta force. You call it total pressure force, you call it hydrostatic force, you call it total pressure. All are the same thing. All are the same thing. Now, let's see quickly how we can use this formula. We have only one formula. We have only one formula in this topic, that is rho g. P is equal to rho g ax bar. So very simple, sir. Very simple, sir. A rectangular plane surface is 2 meter wide and 3 meter deep. Always remember when we use this formula, beta. When we use this formula, P is equal to rho g a x bar. Now, firstly, so let's not see this A part. We'll move directly to the B part. No problem. No problem. Beta see, rho g ax bar. So always remember this A firstly is surface area. This firstly is surface area. Again, surface area. And see, if you see the second part, so this rectangular surface, so this is some liquid, this is some water is here, this is the water here, and this surface is placed like this surface is placed like this surface is placed like this, beta. Okay, this surface is placed somewhere like this. So where is the surface, beta? How you are seeing it, beta? Like this. You see my mobile. From this mobile I am seeing your comments only. So this mobile, you can see this surface. This is the line. If you see it in the front view, you will be able to see this line only. So where is this surface? See, this screen is going to be your surface. This screen is going to be your surface. This screen is going to be your surface, which is perpendicular to the plane of the screen, which is the perpendicular to the plane of the screen, which is perpendicular to the plane of the screen. So this is where I made this rectangle. Now, if we talk about this area, so this is surface area. Which area they are talking? This area, beta, this area. We do not need to do anything with the thickness. This thickness we do not. Yes, Vijay, your answer is correct. The answer is correct. Now, this thickness, we have nothing to do with this thickness, beta. Nothing we have to do with this thickness. Okay. We need this width and this length. We need those two things. We need these two things. We need this width. We need this width. And we need this depth. We need this depth. Getting my point? Okay. So this surface area, if it is a case of rectangle, it will be B into D. And similarly, if it is some any other geometry, similar way you can find that. Now coming to this X bar. Now please read what this X bar is. In the formula sheet, please read what this X bar is. X bar is the vertical distance of centroid of surface taken from free surface of fluid. Okay, free surface of the fluid. So where is the free surface, beta? Where is the centroid? So centroid is somewhere located here. Let's call it G in the geometrical center. So let us call it G. So what is this X bar, beta? This X bar is the vertical distance. This X bar is the, yes, Vaishnavi, your answer is correct, beta. So this is my X bar, beta. This is my X bar. Okay. So in this case, what is this X bar? In this case, what is this X bar? So this D is given to be, this depth is given to be 3 meter. This depth is given to be 3 meter. Okay, this is 3 meter. So this will be what? This will be 1.5 meter, isn't it? This will be 1.5 meter, yes or no? This will be 1.5 meter. And if this plate is located 2.5 meter, if this plate is located 2.5 meter, this plate is located 2.5 meter below the free surface, 2.5 meter below the free surface. What will be this X bar, beta? This will be 2.5 plus 1.5, that is 4 meter. 2.5 plus 1.5, that is 4 meter. Is it or isn't it, beta? Yes or no? Now, once we have this x bar, we can have, sir, rho G is 9.81, G is 9.81, A is surface area, width is given to be 2. So 2 into 3 into this x bar, that is force. So I believe this pressure, this hydrostatic force, this is not P, this is H. This is hydrostatic force. So you can say this is H, call it as H, because P we usually denote with pressure force. So this is coming out to be, as Vinay is telling me, sir, very nice, 235.44, 235.44 kilonewton. Getting my point? Getting my point now. Now, sir, this is very easy question. This is very easy question. Similar way, center of pressure, sir, H bar, we can calculate, sir. IG by AX bar, sine square theta. So plate is vertical, so theta is 90. So for vertical plate, we can use this IG by, हाँ गिरीश, PDF ही मिलेगा बेटा, सारा PDF मिलेगा, do not worry about it, सारा PDF मिलेगा, ओके, सब PDF में मिल जाएगा, कोई दिक्कत की बात नहीं. चैनल सब्सक्राइब कर दो आप लोग, है ना, चैनल सब्सक्राइब कर दो, इसके वीडियो के डिस्क्रिप्शन में, ठीक है, लास्ट लेक्चर में हम सारा PDF बना करके डाल लेंगे, ठीक है बेटे, ठीक है. So this H bar is IG by AX bar plus X bar. This H bar is IG plus A upon AX bar plus X bar. Now X bar मिल गया, we have got this X bar, we have got this X bar, we have got this X bar, we have this area, no problem in this area. Now what about this IG? Sir, IG we know for rectangle it is BD cube by 12. So sir, B is given, D is given. I'll place all these values here. So again, sir, I'll be getting H bar. And as some of you are already giving me the answers of it, Vaishnavi, you have given me answer to be 4.186. Piyush, beta, you are given me 4.023. But I am not writing answer here. Whatever is the answer, will you be able to calculate it or not? Yes, sir. Yes, sir. We will be able to calculate it. We'll be able to calculate it. So can you tell me what is the answer? Can you tell me what is the answer here? Beta? Can you tell me what is the answer? Okay, so it is 4.1875, as you are telling me. It is 4.1875. 4.1875. So we are getting 4.1875 meter. Okay, 4.1875 meter. All right. Now, please understand this very, very carefully. Be very, very careful about it. Whatever, see, solving this question wasn't the purpose. Explaining the concept was the purpose. Now we can calculate the magnitudes. Now, tip number one, score booster tip number one, beta. Firstly, this hydrostatic force is due to pressure, and pressure is always normal to the surface. Yes or no? We all know it. So this is somewhere G. Now, first of all, always draw, wherever we draw this force, always draw this force perpendicular to the surface, and where this force will be applied, at center of pressure, that is H bar. Getting my point or not? Always remember that this force is perpendicular to the surface. Now, if I place this surface like this, beta, if I place the surface like this, incline I made it incline. The same thing if I made it incline. Now this will be your this. Now in the incline case thing, this is your theta, which we have mentioned in the formula sheet also. This is the formula sheet, na beta. This is the formula sheet. This is the center of pressure. This is the total pressure or hydrostatic force. Now in this, firstly tell me what is this X bar? What is this? So this is somewhere G. This is the G. So what will be the X bar? So X bar is the perpendicular distance. Always remember these points. You will never make a mistake. This is x bar. This is x bar. It is always a vertical distance. See the formula sheet. See the formula sheet. Okay. See the formula sheet. See, I have written all these things so that we can maximum utilization of time we can do. Maximum utilization. No time wasting here. No wastage of time here. Okay. No wastage of time here. Okay, so vertical distance of centroid of surface taken from free surface of the fluid, free surface of the fluid. So this will be somewhere the centroid of this plate, and if I always have to see everything vertically, vertically. Now secondly, beta, this force, whatever hydrostatic force, whatever this hydrostatic force we will be getting, rho g ax bar. So certainly, sir, we can find this x bar. Certainly, we can find this x bar. Now, some people of you, some student might of you may face difficulty in trigonometry also. Sometimes we make silly mistakes also. So I tell you, I give you a shortcut for this also. So if this is given, most of the question this is given h1 and this is given to be h2, or by applying simple trigonometry geometry, we can calculate this h1 and h2. Okay, we can calculate this h1 and h2. So once you have this h1 h2, trust me on this, you can do this. You can cross check it to any case. Just simply do it. Believe me, h1 x bar is equal to h1 plus h2 by 2. h1 is the distance of this top edge from the free surface. h2 is the bottommost edge from the free surface. All the vertical distances there. Now the second most crucial point, always remember, sir, that this pressure, this force, this hydrostatic force, we may call it F also. Let's call it F also. Let us call it F. So this hydrostatic force beta is always acts perpendicular. Always acts perpendicular to the surface. Now surface is inclined, so the force, the direction of the force should be this. The direction of the force should be this. Yes or no? The direction of the force should be this. Yes or no, beta? Yes or no, beta? Getting my point? And where will be your h bar? Where will be your h bar? Where will be your h bar? Now see this line coming. This is a horizontal line coming out of it, from it. This is a horizontal line. This is your h bar. The point. All distances are measured vertically, and remember the force is always perpendicular to the plane, to the surface. Is that clear or not, beta? Is that clear or not to everyone? Say yes or no. Is that clear to all? Yes or no? Yes or no, beta? Please tell me. Please tell me. Now, using all these concepts, I want you to solve this question number 6. Let me copy it there. Let me copy it there. Let me copy it there. Okay. Now let's do this question. Now let us do this question. All right. So is it visible? Let me increase the size of the font. Okay. Okay. Now please solve this question and give me the answer. You have this question on the screen. You have this question on the screen. I require you to solve this question and give me the answer. Okay, I have drawn it. Okay, I have drawn it. All the necessary things are given in the question. And before you solve this question, beta, again, it's the score booster. So one more tip. In this subject or in any subject, whenever you see a hinge, just prepare yourself that somehow we are going to take the moment about that hinge. Getting my point or not? Let's try and solve this question. Beta. All of you. Let's try and solve this question, all of you. Let's attempt this question. Let's attempt this question. Please do this question. And meanwhile, while you are doing this question, please do like, subscribe, share the GATE Academy English channel, Hindi channel. Please do it. Also give me the feedback, any suggestion you want me to take up in the next session. This formula sheet is helping you or not? The formula sheet we have prepared, is it helping or not? The way we are approaching, in this session, some concept also we are discussing, some questions we are doing, that is fine, or we want to some improvisation. Your suggestions, guys. Please suggest, if anything you want to suggest, please suggest us. We'll definitely try to incorporate it. Any suggestion is very much welcomed. Please feel free to share your feedback, suggestion if you are liking this video, if you are liking the session. Mahadev, I'll try to, beta. I'll try to. Okay. But like velocity diagrams, how to make velocity diagram if you want to see. So you can see in the GATE Academy channel, you can see the fluid mechanics whole lecture series. Okay. Otherwise, if you want to see it from me, you can go and watch some previous videos in which we have explained gas turbine and steam turbines on this English channel, English the GATE Academy channel. You will see the new GATE additional subjects, additional topics which were added in the GATE 2021 steam turbine and gas turbine session. So in that steam turbine gas turbine session, I also explained how to make velocity triangles. So you can refer from that. Okay. In this session also, I'll try to. I'll try. I'll try to. I'll try to. Okay, now what is the answer to this question? Vinay, you have given me some answer. I'll check. I'll not disclose the answer. Otherwise, your friends, engineers have this tendency, na beta. Once we know this, the answer, somehow we'll be able to get it, no matter how. Okay. That is why I refrain myself from telling the answer beforehand. When I solve it, we'll see the answer. No worries. No worries. No worries. Now, all of you, please see, all of you, let me solve this question now. Let me explain this question now. Now, flow of water from a reservoir is controlled by a 1.5 meter width L-shaped gate hinge at point A as shown in the figure. If it is desired that the gate open when the water height is 3.5 meter, the mass of the required W is. So here we have some water. Now, can you feel, beta, that there is some surface exposed to this liquid? This gate is like this, like my calculator. So this water will be on this surface, this water will be on this surface, and this water will be on this surface. and this water will be exerting, some force on the surface, yes or no? This water will be exerting some force on this surface, yes or no? Now what force it will be exerting, sir? It will be hydrostatic force, that is rho g ax bar, and sir, it will be applicable, it will be acting at h bar, h bar, h bar from the free surface, free surface, and is g will be, is x bar will be this, now what will be this x bar? What will be this x bar, beta? This x bar will be 1.8 meter, 1.8 meter. This x bar will be 1.8 meter. Now if I do it, so this rho is 1000 into 9.81. What is the surface area? It is 3.6 into width, that is 1.5, that is 1.5. We have to give answer in kg, beta. Dekho, see the question, and this is 1.8. So what this f we are getting? What f we are getting? Please tell me, everyone. Please tell me, everyone, beta. Please tell me, everyone. What f we are getting, beta? Please tell me, everyone. So we are getting 95353 newtons. 9595353 newtons. Now secondly, we need to calculate this h bar. Why we all are doing this? Because sir, once I see the hinge, somewhat from my heart a voice came that I have to take moment about it. Now for taking the moment about hinge, I need all the forces. So this w is acting, this w is acting downward, this is weight, this w is acting downward, this is weight, yes or no? This is weight. Getting my point? This is weight. Okay, this is weight. All right, this is weight. So this is acting downward. So all we have to do, if we have to take the moment about the hinge, so let us call this distance to be somewhere, just name it anything. Let's call it y. So ultimately I have to do this, f into y is equal to w into 2.4, w into 2.4. Now I have calculated this f, no problem. I have to find this weight, I have to find this w, Now if I get this y, my question will be solved or not? If I get this y, my question will be solved or not? Say yes or no. My question will be solved or not? Yes, sir. Certainly it will be solved. Now if I get this h bar, if I be able to get this h bar, will I be able to get this y? Certainly, sir. So this h bar will going to be Ig by Ax bar, Since it is a vertical case, so we need not to take theta, or you take theta is 90, sin square theta will be 1. No problem, sir. No extra burden to mind. Now can we take Ig? Yes, sir. It will be Bd cube by 12. So 1.5 into d, that is 3.6, Bd cube 3.6 cube by 12 into area, this is width, into depth, that is 3.6, into x bar, that is 1.8 plus 1.8. So can we calculate this h bar, beta? Please tell me what is this h bar. Please tell me what is this h bar. What is this h bar? What is this h bar coming out to be? Can somebody please tell me what is this h bar coming out to be? What is this h bar coming out to be? Now let me calculate it. Okay. So it is coming out to be, thanks for helping me, Vinay and Shahrukh. So this is 2.4. This is 2.4. This is 2.4 meter. Getting my point? 2.4 meter. H bar is 2.4 meter. Now we have this H bar. Now if this is 2.4, This is 3.6. So this distance will be 2.4 minus 3.6. 2.4 minus 3.6. It will be 1.2. It will be 1.2. Now this much is 4.5. 4.5 minus 1.2. 4.5 minus 1.2. 4.5 minus 1 by 2. That is 3.3. That is 3.3. Getting it or not? Now we have this y also. Now from here, can we get our w? Can we get our w? Yes, sir, we can get our w. And this w will be 95353 into this y, that is 3.3, into this y, that is 3.3 divided by 2.4, divided by 2.4. Now please remember, this is not the answer because you are placing it in Newton. When you are placing it in Newton, this will come out to be Newton. So whatever it is coming here, just convert it in mg. Please do not be in hurry in examination also in giving the answer. Nobody is going to give you a prize for it. Okay, you will get the prize only when you give the right answer at the right place in the GATE examination center. Getting my point or not? Do not be in hurry. Many of you were in hurry and giving me answers in kilonewton, Newton, sir. You will get 0 marks. You will get 0 marks. This is not a conventional paper in which invigilator will or examiner will see the steps and will give you some marks and you will get the passing marks and we will get our BTech degree and all. Getting my point or not? Answer correct is correct. Incorrect is wholly incorrect. 0 marks. 0 mark. Now, is this question understood or not? Now, whatever it is coming from here, we can place it. We can place it and get the answer. Yes or no? Get the answer. 95353 into 3.3 divided by 2.4. So it is 48610. It is 48610 Newton somewhere. And if we divide it by 9.81, so we are getting 48610 divided by 9.81. So we are getting 4955. Right? Have I made mistake in calculation or what? 3.3 divided by 2.4. Okay, my mistake. This is 3. Okay. No, I have did it. Okay, my mistake. I was making a calculation mistake. So divided by 3.81. Yes, we are getting 13,365 kg. Okay, 13,365 kg. So what is your answer, beta? What is your answer? Your answer is 13,365 kg. Is that clear or not? Tell me. Is that clear or not? Tell me, all of you. Is that clear or not? Easy question. Now you see similar kind of questions are getting asked in GATE examination as well. Similar sort of questions are getting asked in GATE examination as well. Okay. So I want you to see one GATE question and just tell me if we will be able to do it or not. See, the intention here is not to solve questions, not to solve GATE question. The intention here is that if you are spending your 2 hours or 2 hours, I always take, whenever I take class for 2 hours, I always take half an hour above. So for this 2.5 hour class, whenever we are doing, so ultimately you must be getting something out of it. Okay. Now in this question, you can read this question. Some editorial mistakes are there also, but I hope this is 1000. This is 5 meter. Now please read it and please tell me how will you do it. A hinge is there. So what is the tip? Whenever a hinge is there, we need to take moment about the hinge. So there will be F. We will be able to find this H bar. Using the formulas. Yes or no? And ultimately, this will be the weight of it. I'll take the moment. I will apply the formulas and I will be able to solve the question. Are we confident enough or not? Please tell me, are we confident enough or not? Yes or no? Now, can I place a tick here also? Hydrostatic force, these formulas are completed. Yes or no? Now, in this hydrostatic force chapter, there is one another case, and after this discussion, we'll be concluding this session because we already have exceeded the time limit. So in the next session, I have planned to do the buoyancy in this session also. But buoyancy we can see in the next session. Buoyancy, kinematics, dynamics, and everything we can see in the next session. So the second case of this hydrostatic forces is hydrostatic forces on these curved surfaces. Where on these curved surfaces? Where on these curved surfaces? So whenever beta a curved surface is there, just remember this curved surface, and I have written it in blue because this is not getting very frequently asked. This is more important as far as this chapter is concerned, but we have to see everything. Okay, so in this formula sheet, this curved surface is there. So in this curved surface, so whenever we talk about this curved surface, so in this curved surface, hydrostatic force have two components. A quick revision, beta. Two components. One is horizontal, one is vertical. So one is horizontal component, other is vertical component. So in a horizontal component case, all you have to do, you have to use the concept of the plane surface. You have to use the concept of this plane surface, the plane surfaces. Okay, so let's say this is a curved surface like this. Let's say this is a curved surface. Where is the curved surface? Curved surface is like this, my hand. This curved surface is inside the plane of the screen. So on this curved surface, we have this water everywhere. We have this water or any liquid, let's say, everywhere. Yes or no? Now this liquid will exert some hydrostatic force by virtue of pressure. Yes or no? Now for horizontal force, just forget that this is curved tip. Okay, score boosting tip. Okay, just forget that this is a curved surface. When you are finding the hydrostatic horizontal component, just forget it is a curved surface. Just take a projection of it. Now, if I forget this AD part, and I only see this AD dash part, it is just similar to what we have seen above, like this, just similar to what we have seen above. Okay, what we have seen above. So let's say this is having a curvature of R. So what will be the hydrostatic force, horizontal force? What will be the hydrostatic horizontal force? Same formula, rho G AX bar. What will be this X bar, sir? So it is the G of this vertical projection. And this is this X bar. Getting my point? This is this X bar. So it's the same way we will be able to find this X bar. We will be able to put all the values in this, and we will be able to get the hydrostatic force, horizontal component of this hydrostatic force. Yes or no? But do remember to take A. So when we see this radius, we again are tempted to, so this is looking like a quadrant of circle. So we are tempted to use this. No, beta. I said just forget it is curved. So when we have forgotten it is curved, this area will be similar to a plane surface, that is width into depth. So if the radius is R, this is nothing but R into B, where it is width, it is width. So normally sometimes we get confused in it. Okay, So will we be able to use this formula FH? Understood this or not? Tell me yes or no. Understood. Now coming to this vertical force. So what it is written in the formula sheet? What has been written here in the formula sheet? Weight of the liquid supported in the curved portion. What is the weight of the liquid supported in the curved portion? Weight of the liquid supported in the curve portion. So we have how to find it. We have how to find it. We have how to find it. So we have this liquid. Now we are going to talk about this vertical component. So this is a curved surface. This is a curved surface. Now on this curved surface, please tell me, can we see how much liquid is supported on this curved surface? So this much, let's say A, B, C, D, E, yes or no? So can we say, I am highlighting this part out. Let's highlight this part also. So if I highlight this much liquid in this region is getting supported on this curved surface or not? Please tell me. Now, in order to find the weight of this liquid, so we all know to find the weight, how to find the weight, So the weight will be density into G into volume, isn't it? The weight is density into G into volume. So we can certainly find the value of this shaded region, this highlighted region, and we can have our vertical force. Is that clear or not? Is that clear or not? Is that clear or not? Now, sir, we can also see, sir, you have written real or imaginary. Now, what does that mean? So, what do we mean by what I meant by it? So, here, if the curved surface is like this, we can actually see the amount of liquid which is being supported, amount of liquid which is being supported. But if I see the curved surface like this, if I see the curved surface like this, if I see the curved surface like this, if we see the curved surface like this, on this curved surface, horizontal force, we can simply find some rho g x bar. We will take the vertical projection, we will consider it like a plane surface, and we will give the answer. We will get the answer. But what about, sir, the vertical force? What about this, sir, vertical force? So this vertical force, sir, we cannot see any liquid supported on it. We cannot see any liquid supported here, any real liquid supported here. So let us assume the imaginary liquid. So if we assume the imaginary liquid, this imaginary liquid would have been supported. In this region, yes or no? Would have been supported in this region, yes or no? Yes, sir. Yes, sir. So whenever you cannot see a real fluid being supported, you find the imaginary fluid which would have been supported, So it will be rho g volume of this region A, B, and C. Volume of this region A, B, and C. And one last important thing, beta. Since this is a real fluid which is getting supported, we all know that the weight acts upside down. The weight acts upside down like this. Upside down like this. So this is my vertical force. So whenever real fluid is getting supported, it is acting upside down. Like the weight. But when we take the imaginary liquid, fluid, the vertical force would be acting opposite to this, means acting from downwards to upward direction. Is that clear or not? So can we say that this formula sheet is discussed and cleared? This formula sheet is discussed and cleared up to this point, up to this hydrostatic force. So in this 2.5 hour, almost 2 hour 15-minute session, we have completed these 3 chapters of fluid mechanics. Getting my point or not? So in the next session, beta, please do not miss the class. In the next session, we will be starting with buoyancy, kinematics, dynamics. Okay, and then we'll see the miscellaneous topics. And if time allows, I'll tell you how to quickly solve problems of fluid machinery also. fluid machinery also. For that, you need to support. Okay, you need to support. Getting my point? Getting my point? All right. All right. So please give us the feedback of the classes. Please give the feedback of the class also. Did you like the session or not? You guys like this session or not? Can you please tell me? Have we liked this session or not? Are we going to come in the next sessions also? Are we coming in the next sessions also? All right. So please do like, subscribe and share. Do like, subscribe and share to your friends also. So that everyone has the benefit. Okay. Okay. So thank you very much, everyone. I hope you liked the session. Please do not miss the next Sport Booster sessions. We'll be concluding, completing the whole fluid mechanics session like we have done. We have done today. Thank you very much, Vijay. Thank you, Javed. Thank you, Tiash. Thank you, sir. Thank you, everyone. So let's meet each other in the next Score Booster session of fluid mechanics. In the next sessions, we will be concluding. We will be doing the. We will be doing the. We'll be doing the buoyancy, which is left in the statics, dynamics, kinematics, and everything. Okay. So thank you very much. Do not forget to like and subscribe the GATE Academy. Thank you. Thank you very very much, Vitas. Thank you very very much. So we can subscribe. If there is a feedback, we can send it here. We can write the feedbacks in the comment section also. We can write the feedbacks in the comment section also. So thank you very much. We'll be seeing each other in the next Score Booster session.